Hi guys, I'd like to take just a minute to show you a new feature of QuickPlumb software that will size your water distribution pipes for you. If you've ever looked at the code book and tried to calculate pipe sizes, you know that it can be a daunting task indeed. You want to make sure there's sufficient pressure to all fixtures, but you don't want to waste money by oversizing pipes. QuickPlumb uses tried and true methods that are universally accepted in the mechanical engineering community. In fact, they are taken directly from Appendix E of the International Plumbing Code and Appendix A of the Uniform Plumbing Code. When we set out to develop this feature, we agreed that first we would have to provide a platform that would be easy to use, intuitive, and would make it easy to connect piping to fixtures. QuickPlumb already provided that. Secondly, we knew that it had to be accurate. I'm happy to announce that these criteria have now been met. Let's take a look at the procedure. First of all, we import our plan from the PDF file, or bitmap, or JPEG. So we'll just draw a few walls. The main walls we're concerned with are the ones that are adjacent to plumbing fixtures. Having drawn the walls, we will then import the fixtures by simply dragging them from the toolbar onto the plan. Now that we've placed our fixtures on the plan, we can turn off temporarily the background that we imported, so that we only see the fixtures and the walls. Now we're ready to begin to draw our water distribution piping. We click Water, decide where we want to enter the plan, and draw a short line entering into the crawl space. Set the depth, and now in the front view I'm going to bring my water main up under the floor system and drag it over under the floor. Now I'm going to connect my fixtures. I can connect my fixtures in any order that I choose. I'm going to connect my cold water piping to the cold water branches. Once I have all the cold water piping connected, I can then begin to connect the hot water pipes. Notice how easy it is to connect piping to fixtures. I can click anywhere within the boundaries of the fixture and QuickPlumb will find the water connection for me. And I just drag a pipe over to the branch. And I'm not concerned with pipe sizes at this point because I'm going to let QuickPlumb choose the pipe sizing for me. Now that we've connected all our pipes, we're ready to let QuickPlumb calculate the pipe sizes. We click on Tools, Autosize Water Distribution, and here we enter some key information. We've already selected Type M hard copper as our piping material. It has a coefficient of friction of 140. Minimum pressure available at the meter, we've already checked and it's 55 psi. QuickPlumb looked at all the fixtures on our drawing and determined that the highest pressure required at any fixture is 20 psi. The pressure drop of a 5/8 water meter at 10.7 gallons per minute is 4.4 psi. The pressure drop due to the 5/8 tap is 5.38 psi at 10.7 gallons per minute. Since this is residential construction, we will not be using a backflow preventer on this job, so I will click None there. Now the static pressure required at the highest fixture is 3 psi. That's the pressure drop, or the pressure drop due to the elevation of the fixture. Water filter pressure loss. If there's a water filter pressure loss, you'll enter it here, and any other pressure loss should be entered here. Maximum velocity. This is where we set the maximum velocity we want at any pipe in the plumbing system. Now that these are all set and verified, I'm going to click the acknowledgement button and then click Go. QuickPlumb is now analyzing the drawing and determining the best pipe size to achieve our goals. As you can see, this is a much simpler method of determining pipe sizes. At the same time that QuickPlumb generates this report, it also downsizes all of our piping in our drawing. So we're instantly able to create bills of material and estimates. You can easily check the effects of different piping materials by changing the pipe material in the customer selection dialog box. Here we'll change from M hard copper to schedule 40 CPVC. Having selected CPVC as a piping material, we simply go back to Tools, click Autosize Water Distribution, and we see that CPVC Schedule 40 is in the material field. Now we simply click on Go, and our report is generated. We can also look at the effects of changing the maximum velocity. Let's say, for instance, we want the maximum velocity to be 5 feet per second instead of 10. Enter a 5, click Go. As we can see in the velocity column, none of the pipes have a velocity greater than 5 feet per second. And we can also see that reducing the maximum velocity resulted in an increase in pipe sizes. We can also check the effects of adding a sprinkler system to the water main by teeing off the water main and dragging irrigation valves and sprinkler heads onto the project. When we right-click a control valve and select Properties, we see that we have a group setting. All irrigation control valves that have the same group number are considered to be connected to the same sprinkler controller. This means that only one valve will be open at any given time. QuickPlumb finds the valve in each group that has the highest flow rate when calculating total gallon per minute demand. Sprinkler heads feature a radius of coverage circle, which makes it possible to use QuickPlumb to plan out your sprinkler head placement. Click on the eye in the upper right corner of your screen for your free 30-day trial of QuickPlumb software. We know you'll enjoy its benefits. Thank you.